Should mean that I know what I'm doing, but yeah, it's up to you to decide. If that's okay for you, you can follow me on Google+, on Twitter too, and I've got a blog. I try to post interesting and technical stuff. So yeah, you can go ahead. First, who is targeting Android platforms in the room? When developing games, of course. I mean, not with guns. Okay, quite so many. So who has already some experience with the Android NDK, the native development kit? Okay, I was expecting a little bit more people for game developers audience. Okay, thanks. It changes everything. My number was like one people, and perfect. Thanks. So I maybe talk more about what is the NDK, because not many of you already know. So yeah, I've chosen a broad title, so I could adjust the content a lot. C and C++ for Android devs. So I'll talk about the Android NDK, which is the thing you use to do some C and C++ for Android applications. I'll talk about the JNI, so that's the Java native interface. These are all the concepts that allow us to mix C and C++ with Java. And by the way, Java is the main language when developing Android apps. I'll talk about Android Studio and Gradle, so the build system, C and C++ supports, especially because there have been many news since a week from now with new releases that are experimental, full of bugs. That's a lot of fun. And I'll mention other IDEs too you can use to develop in C and C++ for Android. And in the end, if you've got some time, Q&A. So first of all, the NDK. So the NDK is an official component from Google. You just download it. Inside it, you got tool chains, platforms, compilers that allows you to cross-compile C and C++ sources into shared object libraries you can later use inside Android applications. So it allows you to compile C and C++ and use it in Android applications. And that's the official component from Google. So it's really useful for people who want to just create one big OpenGL code base and share it across platforms, for example, iOS and Android, because OpenGL is almost the same on this, so to share a maximum of code. So this, in that case, you can directly use the NDK and you've got samples to just write your OpenGL code and get it working on all the platforms. So the way it works, so I mentioned you compiled C and C++ sources, etc. But to have these available in Android applications, you need to understand what is the JNI, so the Java native interface. Because all the Android framework, all the Android applications are relying on Java. So they are executed by the Android runtime, that is meant to execute Java bytecode and so on. So everything you integrate with on Android, it's not native low-level stuff usually, it's a Java world. And to talk to a Java world, you need to understand the JNI. So JNI isn't something new introduced with Android, that's something old introduced with Java, and many people already used it on server stuff for a long time. So on Android, how it works, and in fact it's quite standard too in this part, so on the Java side, you call system.loadLibrary, and you'll use this method to load a .so file, so a shared object library that contains your binaries that you have compiled from your C, C++ and assembly. And then on your Java side still, you've got a native keyword. So you put this native keyword in front of any method, and that means that this method will be implemented in a .so file. You've been loaded with load library. So on the C, C++ side, you've got the jni.h header, that allows you to implement everything you told Java it was going to be native in your C and C++ sources. So you have access to Java primitive types like int, JLong, and so on, Java objects, so JObjects, JStrings, and so on. Because you talk to Java, you need to handle Java objects. And you have access to JNI and then Java VM. So these are both objects that allows you to talk to the Java virtual machine and the Java environment. All these concepts are especially important if you are looking for a simple Hello world where you have an Android application written in Java, and inside your Java you load the library and you have C and C++ implementations. Because that's the usual way to do things on Android applications. So usually you don't have just one Android application written only in C++. You always need to have some parts of Java. These parts of Java can still be written in C and C++. That's the magic of JNI. You can write Java in C and C++. That's ugly as hell, but you need it. And you can even create a new activity, which are the main views on Android, all from C and C++. And you don't want to reach that level of ugliness. So you already have a native activity.h header that is part of the NDK, and you can use it in your apps. That's part of the framework, and that allows you to instantiate all the Android views and OpenGLES context, and you directly get actually two threads, a main thread for messaging and a render thread, and you get going with your OpenGLES code. You can integrate with it. So that's a specific case that allows you to create an Android application with almost no Java, actually no Java written from you. So when you load the library and you want to map the implementations to the Java method that has been declared native, you need to implement these methods using a specific naming, and you need to return Java objects and get Java objects. So the convention when using JNI is this one. So you need to return Java primitives objects, and you get at least two variables. So the first one is always the JNI environment, and then it's a J class if it's a static method, or a J object if it's just a method. And for the second variable, you get the instance of the object or the name of a class. Not the name, but the actual class. And then everything can be automatically mapped if, as a function name, you use this ugly as hell, again, it's JNI, name. So starting with Java, followed by package name, then the activity, the name of the activity, sorry, and then the name of the method. If you want to do something cleaner, you can manually call register natives on this JNI, and you'll get on all the methods you implement for JNI. So using register natives, you can use whatever name you want, and you just give a function pointers. That's cleaner. So I mentioned JNI types like 10 times. Here they are. Everything inherits from J objects, and you can have arrays of these primitives. And the primitives are there because, yeah, Java is cross-platform, and you need the same size for all the elements you deal with on Java, but on Android, you can have Android devices running on ARM architectures, x86 architectures, and sometimes the sizes are not necessarily the same if you just take plain C types, which is, yeah, it's a trap. But you get all the JNI.h types, so you need to use these when you return anything to Java world, as you can get many surprises. Bad types of surprises, actually. So when you want to have a really cross-platform code base, you need also to take into consideration that on Android, what you get is not the standard GNU C library. So it's the Bionic C library. Because everyone likes to rewrite C libraries all the time because, yeah, everything that has been done for 30 years is not as good as it is, so, as it could be. So everyone's redoing it, Google included. So there is Bionic. It's lighter than C library. That's a good thing. It has been meant for embedded world. Makes sense here on phones and tablets. But yeah, it's not binary compatible with C library. Some things are missing. I'm not sure you can even close threads yet. You don't have all the shared memory segments you would find on other platforms, but you have access to specific Android stuff. That means that in general, every code you have, you should at least recompile it and, yeah, see what happens first and then fix it. But you can't link usual Linux library on Android unless everything is static inside, like a specific case, but no. And if you want to go to C++, well, by default there is nothing. But the good thing is by default inside the NDK you can choose which C++ runtime you want to use inside your app. And that will provide more. So by default, the system C++ runtime provides objects and no STL, no exceptions, no. basically nothing, only objects. But if you want to activate more things, you just choose another runtime. So all these runtimes listed here, you could ask why 5 of them. There are different licenses, so some of these are LGPL, some of these aren't. You need to check with a lawyer, not with me, as usual. And they provide different support. So some of them provide more STL stuff. For example, I remember C++ and GNU STL are the one that provides the most of C++11 and the standard template library. And the others provide a little bit less. Sometimes you have to choose if you want to use std-chrono or if you want to use std-thread. It's not always available on all the C++ runtimes. When you want to choose a different C++ runtime, you do it using the standard Android makefiles. I'll talk more about this for those who don't know the NDK. But in application.mk, you set the application-wide variables, and in app.stl, you choose your C++ runtime. Each of these C++ runtimes can be used as a shared or static library. So shared, it's a separate .so file, and static, it's all compiled into the same .so file. Again, check with a lawyer. And if you're using expression and RTTI, you still need to explicitly say inside your Android.mk that you're going to use these features. When you have .so files inside an Android application, so the classic execution flow is you call system.library, usually in the static block of a class. So it loads the .so file. And then later, when your Java encounters some method that has been declared as native, the Android runtime will directly execute the native implementation for these methods. There is no new thread or whatsoever. Everything is, and you don't go outside of any sandbox. Everything is executed in the same context of the Android runtime by the calling thread. And once the native implementation has been executed, it goes back to the Java. So it's really seamless. But that means that if you want to do some heavy processing on the C and C++ side, you should instantiate some threads. As usual, you can create threads from both Java or C and C++. These are the same kind of threads. If you create a thread from C and C++, you still need to attach it to the JVM. Else, the lifecycle of the thread can go wrong, sorry. So now about Android Studio. So the NDK has not always been properly supported by Google, I'd say. If you take an example, so the usual IDE for Android for a long time was Eclipse. And then 2 years ago, they released Android Studio in alpha, or I'm not sure. And they quite stopped to support Eclipse. And at last Google I/O, end of May, they simply made everyone switch to Android Studio. But big difference at this time between Android Studio and Eclipse is Eclipse was perfectly supporting, let me rephrase it, Eclipse was supporting C and C++ code editing and the NDK. And then at this time, Android Studio wasn't at all. Like, yeah, there is the same support as Notepad supports C and C++ editing. That's the kind of support you can get. So. And they say, yeah, NDK support was going to Android Studio 1.3. And so I've been waiting for preview 1, preview 2, preview 3. They say it was coming. So last Friday, finally, we got it. In the RC1, you need to use, everything is experimental, so it's really buggy. The demo looks cool, if you can actually see it. Yeah. I don't have time to launch Android Studio myself, but you can write any method, declare it as native in your Java, on your Java side, and then the auto-completion and the magics of Android Studio allows you to just Alt-Enter, and it will create the right function name and everything in a new C file. And then you just press Start, it will compile your .so files, put them in the APK, and it works. So, which is quite a big change if you compare it with what you had to do before. And there is really a little you can do a really little configuration to change it. So everything goes inside the build.gradle, where you define the NDK module and you give a module name, and that's enough. But yeah, in real life, you usually want to do a little bit more, like defining some variables for the compilers, some C flags, and so on. This you can still do. What is still missing, and you still need to use makefiles for this to work, is if you want to rely on precompiled libraries. If you've got a precompiled version of OpenCV somewhere or anything, it doesn't really work here yet in Android Studio. So they are working on it because everything is experimental, everything may still change, and so on. And we're waiting for it. But while it's not there, that doesn't mean you can't use Android Studio and the full C and C++ editing support. That just means you need to pay attention to what you're doing and maybe sometimes do some hacky stuff. So let me go through the hacky stuff. Yeah, later. I already mentioned all of this, so you don't need the slides. That's a good thing. So if you want to go further than just some C and C++ sources inside an Android project and everything works, you need to still rely on makefiles. So, and use the usual way to use the NDK. That means you call the main script of the NDK called NDK Built. That's the script that is responsible for compiling all your sources to .so files. So when you do so, it will compile your .so files inside the libs folder. And of course, Android Studio will look for this inside GNI libs folder, which is not the same. So you need to specifically tell Android Studio that you want him to look into the libs folder. And your .so files will be embedded. And that's the solution if you don't even declare NDK module inside your build.gradle. So, because if you do declare Android NDK module, Android Studio will try to compile your sources, but it will not work because you're relying on something else and you want your makefiles and so on. So don't do it. But if you want the full C and C++ code editing support inside Android Studio with your other headers or your other precompiled libs, you can still create an Android.ndk block with everything as if you wanted Android Studio to compile the libs himself, but you just put a dummy gni.source.src here. So like this block, but instead of gni libs, it's gni. And you give him just a directory that doesn't exist. And I know it's a bit hacky, but this way you have all the C and C++ editing support with the proper headers that are referenced, and you still compile using your own makefiles. So yeah, some people didn't really know about the NDK, so I should have put these slides earlier actually. But on the NDK project, so you put all your C and C++ sources under a folder named GNI at the root of the Android project. And then you call NDK Built at the root of your Android project, and it generates the .so files. So it does it by looking first at your makefiles. There are two makefiles, android.mk and application.mk. Inside android.mk, you define your NDK modules. So this is the shortest android.mk you can have. So the first line is mandatory. You need to declare the local path. Then you clear your variables. That's a macro from the NDK. Then you define the name of the module, so local module. And here I define hello GNI. Then you give your sources, and then you include the macro that tells the NDK to build your .so file. It's build shared library. You get some other options for macros if you want to create a precompiled library or if you want to create an executable, but that's not required for games, and you don't necessarily need to use these. Then you get other variables. If you have really dependencies between modules, you can declare where are the includes and what's the name of the library of the dependencies. Sorry. Application.mk is not that well known as a makefile, but it's really important because that's here that you define the application-wide variables. The two most important ones are app platform that defines against which NDK platforms you are compiling your sources against. And remember, you need this number so to be exactly the same or lower than your application's mean SDK version. Because all the NDK platforms, they are forward compatible, so you can compile for KitKat to work for Lollipop, but that's not true for the other way around. So if you compile for Lollipop, it will crash for KitKat. So, and you don't really want that. And then the app ABI variable is the variable where you declare all the CPU architectures you're supporting. So by default, I recommend to set it to all, and it will compile for all the 7 different ABIs supported by the Android NDK. If you're supporting only 32 bits, you can put all 32, or you can even list all the CPU architectures one by one. Yeah, that was a quick overview for Android Studio. Forgot to mention, of course, now the support is really good in Android Studio because they integrated Sea Lion from JetBrains inside Android Studio. So, of course, you get refactoring, syntactic correction, but you also get full debug support with GDB or even LLDB as backend, so it's working really well now. But you may also be interested in other ideas, so you can still use the good old Eclipse if you got used to it. You can still have the Android tools, you can still compile Android APKs with it. The NDK support isn't that great, in my view, because you always need to configure everything twice. So once for Eclipse to understand where are your headers and so on, and once through your Makefiles to make the NDK understand where are your headers and so on. So it's not always reliable, and I quite hate it actually. But yeah, that's up to you. You can also use any version, almost any version of Visual Studio with some plugins like VS Android. There is also Android Works from NVIDIA, which packages everything and makes you able to get your projects running from Visual Studio. And now also, like in 3 days from now, you can use Visual Studio 2015, that just provides Android application templates like the native activity, and you can even have, and it's working well. It integrates all the tools directly. There is no plugin required. They even provide an emulator based on Hyper-V that should work well. And they provide templates too, so you can have templates that shows you how to share OpenGL code across Android and iOS. Yeah, Microsoft's doing that. Maybe unexpected, but quite cool. So here is a review of the templates. So directly from Visual Studio 2015, you go into templates, you get cross-platform templates that allows you to target Android and iOS. Wondering where is Windows Phone actually in that list. Yeah, anyway. That's quite weird. Maybe if I need a different project, I'm sure you can still share code, but that's weird to not have one project for all of these. Yeah, maybe first because it's not OpenGL, yes. So yeah, it's the usual Visual Studio. I'm sure you all know this one. So here it's with the Android native activity project. And yeah, everything's there and works. When you install Visual Studio, you can ask him to install all the cross-platform bits, else it will not work. If you don't want to install the NDK twice and you already have it installed somewhere, you just set it in the NDK root environment variable. It needs to point to a 32-bit version. There is one thing to know, because on Android, nothing is always that simple. By default, let me go back to the overview. When you use Visual Studio, you always have only one target. So this target can be x86, this target can be ARM. If it's C#, you have any CPU, for example, but here we are not doing C#. So it's x86 or ARM. The thing is, by default, if you compile for one architecture or another, it will give you an APK for one architecture or another. But when you go to the Play Store and you upload one of these APK, it will be the only one on the store. Because by default, Visual Studio doesn't care about version codes or anything that are needed when publishing APKs with different architectures on the store. Because let me go back to a screenshot that I avoided before. You can upload multiple APKs for multiple architectures on the store. Like in this screenshot, you just switch to advanced mode and upload all the APKs you want. But these APKs need to have a different version code and, of course, different native code inside. And the bit that Visual Studio is missing is the version codes bit. So you always need to give higher version code for newer APKs, but you always also need to give a higher version code for x86 versions of APKs, because all the Android x86 devices are able to run ARM and x86 APKs. And the store will only give the one with the higher version code. Anyway, that just means you need to copy paste the XML I've shown. This one, so it will prefix your version code with just one digit, and it will fix all the things. And then you can publish all your APKs to the store.